one of the reasons to treat time as an eigenvalue is because an eigenvalue, rather than an integer, can be representative of a progressive series. Now, when people actually use something like Schrödinger's equation to predict the behavior of matter, they find that writing the computer programs, they have to iterate. Over and over again, they do certain calculations. Now, if you can prove that Schrödinger's equation is NP non-complete, based on something clever that mathematicians know about that now, because there's a mathematician that says it's possible to describe whether or not a thing is NP-complete or non-complete. That would prove that Schrödinger's equation had a different solution that more accurately predicted the behavior of matter, which required iteration. So that would completely change the known form of Schrödinger's equation, which would also completely change the many worlds interpretation of physics. Because when people use Schrödinger's equation, they've actually already found a more efficient way to do it that uses iteration. Now, using iteration means that rather than use the integer notion of time to calculate a moment or a static description of functionality, you can use an eigenvalue of time. In other words, a matrix. So that would be a more accurate description of these iterated methods that relate to Schrödinger's equation, which more accurately predict the behavior of matter, specifically semiconductors. But they also do calculations for other things as well. So the fact that iteration, rather than Schrödinger's equation, is more functionally descriptive gives support to creating time eigenvalues, as well as the notion that grouped atoms have refractive indices which are associated with actual change of the speed of light, which goes well with the modifications like E equals hv, E equals mc squared, things like that. To change Planck's constant based on this new idea of time as an eigenvalue.